Today we are going to solve systems of three linear equations. So let's consider the system. 2x plus 2y plus z equals 9, x plus z equals 4, and for y minus 3z equals 17. And notice that the last two equations have a variable term missing. So let's name these equations as equation 1, 2, and 3. And the second equation has a variable y term is missing. And the third equation has a variable x term is missing, right? And basically, in order to solve this system, we need to reduce the system to two equations in the same two variables. Two equations in the same two variables. There are two options. We could eliminate x by using equation 1 and 2, or eliminate y using equation 1 and 3. Let's eliminate y using equations 1 and 3. So in order to eliminate the term y, the variable term y, we have to make the y terms as additive inverses, or in other words, we can say we need to make the coefficient of y as equal and opposite. So for that, we are considering equation 1 and 3. So to eliminate the variable term y from these two equations, multiply the first equation by -2. So then the first equation becomes -4x minus 4y minus 2z equals -18. And consider our third equation, for y minus 3z equals 17. And these two equations together, the y term will be eliminated. So we'll get a new equation, -4x minus 5z equals -1. We can name this equation as equation number 4. So you can see that this equation number 4 is an equation in x and c. And you can see that in our original equation, we have the second equation in x and c. So we can take these two equations together and eliminate one of the variables. So our second equation is x plus c equals 4, and the fourth equation is -4x minus 5c equals -1. Let's eliminate x. For that, we need to multiply the second equation by 4. So we'll get 4x plus 4c equals 16, and consider equation number 4. So -4x minus 5c equals -1. Add these two equations together, then you can see that the x term will be eliminated, and we'll get -1c equals 15. Divide both sides by -1, so z equals -15. So we got the value of one of the variables. Then substitute z equals -15 in equation 2 or 3. So let's substitute that in the second equation, z equals -15. So x minus 15 equals 4. So when we solve for x, it is 19, add 15 on both sides, so x equals 19. So we got the value of two variables, c equals -15 and x equals 19. So we have to find the value of y. So we can substitute z equals -15 in equation 3 So for y minus 3 times negative 15 equals 17, then for y plus 45 equals 17, subtract 45 from both sides. So for y equals negative 28, y equals negative 28 divided by 4, that is negative 7. So y equals negative 7. So we got the value of 3 variables, x, y, and z. So we can write the final solution as an ordered triple. So x value, then the y value, and lastly we have the z value. So the final solution is 19, then negative 7, negative 15. It's an ordered triple. We have to write the solution in terms of an ordered triple.